Hi, in this video we're going to talk about what's called point-slope form of a linear equation. There are different forms of lines. This one focuses on knowing a point, doesn't have to be any special point, and the slope. I will say that I think that this is the most important form to know because it's typically the form that we're going to use in the courses that follow Algebra 1, especially in calculus. So this is the one you really want to remember. So let's get started. Do you remember that the formula for slope is m, right? M stands for slope, equals the difference in the y's, or the change in y, divided by the change in x. Maybe this looks a little different to you because of the subscripts. I just changed it so that instead of this first x and y point having subscripts, it's just a regular old x and y, but notice these would still get paired together, and these are now the subscript of 1. So it's still the same rise over run, a little bit of a different subscript. So remember, that's our formula for slope. Look what happens if we take this equation and we try solving it for y, meaning I want to get this y all by itself. Well, how would I do that? I would have to get rid of this minus y1, and I'd have to get rid of this dividing by x minus x1. So I have to take care of that in the correct order. So here I go. The first thing I'm going to do is to multiply both sides by this denominator. That's what we like to do when we have fractions, right? And we don't like to keep the bottom of the fraction there. So I'm going to multiply by that. I'm going to rewrite this as m times x minus x1. On this side, the reason that we multiplied by that is to cancel out the denominator. So now we just have y minus y1. So I'm hoping that now you can see that getting y by itself really only requires one more thing, and that's adding a y1 to both sides. So now we have m times x minus x1 plus y1 equals y. I'm going to flip it around because we like to see the y equals in front typically. So now y equals, I'm now going to put this side over here, m times the difference of the x's plus the y1. So what we just did was put this slope formula into a form so that it's solved for y. And why do we like to do that? Because that's how we like to work with functions. We like to have the output in terms of the input. This is what point-slope form looks like. So I'm going to write this in. And I'm also going to put some boxes around the things that are going to get replaced with numbers. And this is why I left this as a y without a subscript and this as an x without a subscript. We're going to leave x and y in our equation. So let's fill that in. M is still our slope. Notice how it's getting multiplied with x, but this time it's the difference of x's. So it's very similar to slope-intercept form, right? It's still the coefficient of this, except now we have two numbers here instead of a single number. This is a point on the line. Here's what's very important to recognize. See right here? That's a minus sign, right? We are going to basically be taking the opposite of whatever this says when we write down what the point is. So if we see x minus 1, that means the x value of the point is at positive 1. But notice how in the point slope form that y1 is being added here. that means we're going to take the same. So I'm going to make a little note here. Opposite sign. Same sign. And this is a very common theme. I teach mostly Algebra 2. I do this all day long, where we're working with x's and we do the opposite of what the sign says, and we take the y and we do the same thing that it says. So let's see, how are we going to use this form? Well, we can use it to write the equations now. We want to write the equation of a line that goes through a point. Notice that the point is now not a y-intercept, right? Last topic, we had that point being the y-intercept, and we know the slope. Let me put both of these on the screen at the same time. There we go. So let's write this out. Like I said before, the boxes are going to get replaced with numbers. So everything else is going to stay the same. So I need to put a slope in here. Well, the slope it says is -3. Perfect. Well, we come to another box. Notice how I wrote x minus, and now I'm going to write this -9. Ooh, but -9, I just said that it's going to be like the opposite, right? So I'm going to change that minus to a plus. So now it says +9. That's what I meant by opposite. It looks like it's the opposite thing when it's in the equation, right? You're like, oh yeah, it's a +9, but the point is actually at -9. Okay, and then the last part, so plus, and what's our y1 here? That's going to be at 2. Same sign. So that's how we're going to do it. Let's do another example like that. Write the equation of a line passing through the point 5, -6, and a slope of 2. So same exact type of information. We're going to go right to plugging in. Okay, so our slope is 2. That goes in that box. And then we have x minus. Okay, our x value is 5. We want this to show up as -5, right? -5 being the opposite. Our y value is -6. We want that to be the same. So we'll put -6 at the end. That's it. That's what we're doing. We're putting the slope in the correct place. We're putting the x value, making it look like it has the opposite sign in its correct place, and putting the y value back here with the same sign. Sometimes we have to do a little bit more work. So take a look at example 3. Write the equation of the line passing through the points 4, 1, and 7, -4. So the first thing you might say is, well, now I have 2 points. Which one is the point? Either one of these can be the point. But the more pressing issue is, well, what's the slope? We have to do work to find slope. So let's do that. Let's see. I'm going to do 1 minus -4 for the change in the y's, and 4 minus 7 for the change in x. Let's simplify that. Ooh, minus minus, that's really a plus plus. 1 plus 4 is 5, and 4 minus 7 is -3. Okay, so our slope is -5/3. Now that we know the slope, we need to pick one of these points. I'm actually going to write this equation 2 different ways just to show you that you could write either of them. So here we go. I'm going to say y equals our slope, -5/3. And notice I can put that negative in front. There's just a single negative there. Times, I'm going to go with this point first. X minus 4. Notice it looks like a -4 here. It looks like the opposite, so that's good. Plus 1. So that's a correct answer. I didn't have to pick this one. I could have picked the other point. This is also an acceptable answer. We could do the same slope, except inside here we could do x minus 7, and out here a -4. Either one of these is correct. So this is what we just did, this is a very important skill to have going forward for all high school math classes. Can you take 2 points and write the equation of a line that goes through those 2 points? One more way of doing it would be from a graph. This would be the same thing as being given 2 points, except now you're given many points. So you just want to pick 2 of them, and you can obviously use the graph to figure out slope here. It doesn't matter which. I'm going to use these 2 points right here. And be careful, sometimes the scale on your x and y axes is not going by 1, so just be aware of that, right? So look at how I find slope here. If I'm going up 4 boxes, I didn't actually go up 4. I went from -12 to -4. That's an increase of 8. So just be aware of that. And then from here to here, I know that's 3 boxes, but this is going from 10 to 16, so that's really an increase of 6. So my slope, I'm going to call it m this time, it doesn't really matter, is 8 for the change in y, that always goes on top, over the change in x, which is 6, and I'm going to simplify that. So 2 goes into each of those things, so that turns into 4/3. Look at that graph. It has a positive slope, right? I should have a positive number here. So let's write the equation. Y equals 4/3. Pick a point, any point, I don't care. I'm going to go with this point right here. This point was at 10, -12. So I'm going to write x minus 10, because it was a positive 10, minus 12 at the end. This is one possible answer. There could be many other answers, right? Let's just make a note of that. Okay. One more skill we have to talk about. Notice that all of these were writing the equation of the line, just given different information. Now we want to go the other way. What if we have the equation, but we need to make the line? Just like in slope-intercept form, we listed some steps out. These steps are going to be basically identical. The first thing is that you want to identify a point and plot it. So let's do that on example 5 here. I know it's in point slope form because of the pieces that it has, right? It starts with a y equals. There's a number being multiplied with a set of parentheses. Inside the parentheses is an x plus or minus a number, and then there's plus or minus a number at the end. So I'm going to look at these 2 spaces right here for identifying that point. So we take the opposite of what it looks like for the x, so -2, and the same for the y, so -4. So that was identifying the point, and now let's plot it. -2, -4. Second step, use the slope to find other points. And when I say use slope, right, we like to have it as a fraction. So this 1/3, that's our slope. This is our rise or our change in y over the run or the change in x, right? So I'm going to start at this point. I'm going to go up 1 and over 3. Oops, let me get rid of that line. And I'm going to continue doing that. Up 1 over 3. So I do that in one direction. Now I do it backwards, right? I go down 1, left 3. Down 1, left 3. And that one would put me off the graph. So I'm going to stop there. And the last step, draw the line. Like that. Put some arrows at the end, and we are done. So let's do one more together. I did want to show you that sometimes we need to do a little adjusting when we are looking at an equation. So you look at this and you say, well, hold on, that doesn't start with y equals, but it looks like we have the -2 as the slope, and it's being multiplied with x times x plus or minus a number. It's this -6. This -6 is out of place. So we'll move it, right? Sometimes we want to move things, or some people look at them and they know, like, oh, well, if this had been over here, it would have been positive, right? So I would have taken the opposite. I like the idea of us putting it into a form that we're familiar with. So let's just move that 6 over, adding it to both sides. Okay, so identifying a point. I'm looking at these two spots right here. So our point would be +1, +6. We'll get that on the graph. Our slope is this -2. Oops. I'm going to write that as a fraction though, since I'm going to be using it as rise over run. So I'm going to write that as -2/1. So we're going to go down 2, right 1. Down 2, right 1. Down 2, right 1. And once we finish that, we're going to go backwards. So up 2, left 1, up 2, left 1. And then we will draw in the line and we will be done with that one. Something else you want to take a look at. Example 5 had a positive slope. Look at the line. It has a positive slope. It increases from left to right. Example 6 had a negative slope. It's decreasing from left to right. Right? So those are like little things that are really easy to check, especially if you were taking a test, just to see how you were doing.